morning. That's a whole lot better. Welcome everyone to Windows 10 Security Internals. My name is Chris Jackson. My Twitter handle is @AppCompatGuy. I have learned from previous mistakes, and I no longer have Twitter running in the background broadcasting your tweets on my screen. Turns out that that may not be a wise idea. But I want to kind of set the stage of what we're here to talk about today, and kind of frame it in the context of how this session came to be. So the real topic here is it's designed to be what's going on the internals of Windows applications. We're going to cover things that impact the desktop as well as new universal apps. And then we're going to carry on into what goes into new universal apps. The reality is that security model is not really drastically changed or meaningfully changed even from the security model that we put in place for Windows 8 apps. So if you've seen what we did for Windows 8 security internals, a lot of this is probably going to look excessively familiar, and this may not be giving you what you want. I was highly aspirational to start digging into the internals of some of the things we've been doing, for example, around credential theft mitigation. However, I need to have bits to do that, because this session will be 100% demo. And without bits, I can't really show you that part. It's designed to be an internals talk. As for why it's a 200-level talk when you walk in and there's a console mode debugger sitting on the screen, I don't know. That's very odd to me. That I don't think I've ever in my life given a 200-level talk. I think 300 is the lowest I've ever done. So I don't know how it got wired up that way. So if that is not meeting your expectations, fair warning as well. I'm going to try and make it easy to comprehend, easy to understand, so that you are able to walk out of here really understanding the guts of how application security on Windows works. Are we agreed that that's a worthwhile use of the next 75 minutes of our time? Great. So, as I said, there will be no PowerPoints. But, you know, one of the things that at Microsoft, you're actually required to use PowerPoint. So what I'm going to go ahead and do is launch PowerPoint in the way that you guys always launch PowerPoint. We're going to go ahead and set a breakpoint on user 32, bang, set window text W, and we're going to, you know, just do the typical PowerPoint launch command, EZU, and we're going to modify the EAX register, and we're going to make sure it gets called PowerPoint, titled PowerPoint, you know, it normally says at startup. And then we're going to disable our breakpoints and go conditionally, BD star, semicolon, go conditionally. Same way you normally start PowerPoint. Oh, there's going to be a dramatic pause for the breakpoint setting. I knew I should have done this beforehand. Now we're going to learn how it takes to resolve symbols. So while we wait for that, we're not going to bore you, and we're instead going to go directly into, there we go, what the topics we're going to have, which I outlined briefly. We're going to talk about tokens, and we're going to talk about elevated tokens. And what's really interesting here is I'm presenting on a screen that is being dynamically rescaled, and so the pen is behaving kind of interestingly. We're going to talk about integrity levels. We're going to talk about user interface privilege isolation. We're going to talk about capabilities, which is something that's new in Windows 8 and Windows 10 apps. If you're still on Windows 7, you may not be aware of them. And we're going to talk about app containers. All internal stuff. All of this revolves around a concept in Windows called the access check. What are you allowed to do? The reason why we start quite a ways back, because we really are going all the way back to Windows Vista era, for a lot of these technologies, is that they are really very broadly misunderstood. So I want to make sure that everyone understands why it's there. And when I say misunderstood, to the point where a lot of people today are saying, you know, I just turned off UAC. It sure makes things a lot easier. I get it now. It behaves like what I'm used to. How many people have UAC turned off on your personal device? So a handful of folks. I'm going to try and talk you out of that. We'll see if I succeed at the end. We're going to explain the guts of what's going on behind that. We'll go ahead and get our PowerPoint. Oh, and I have a typo. unbelievable. There we go. Now we've got our PowerPoint. Boy, that was a long, drawn-out joke because I can't type. That's twice already I've been unable to type. Yeah, but now we've got our PowerPoint, which my scaling is messing up my circling. So off we go. So the first thing I want to do is I want to talk about tokens in general. So what I'm going to do is I'm going to bring up a command prompt, and I'm going to bring up a second command prompt that will be running as admin. I'll go ahead and launch command prompt as admin, and now I'll get two of them. And then I'm going to switch back and forth. I'm going to do who am I /all in both of them, who am I /all. And that's going to just issue a command that's going to dump out the contents of my token so I can go through and poke around at them. Now, while we wait for that, I'm going to point out a little bit of a presentation trick, because I like everyone to walk away having learned something. And this is a great presentation trick that you can use to keep track of which of your command prompts is elevated and which are not. There is no magic that's making it red. The magic is that we store those colors per shortcut. I launched the blue one from a Windows R CMD, and that will always be blue, elevated or not. I launched the red one from a right-click command prompt as admin. That will always be red. And that's how I worked that little bit of magic for the presentation. So it's dumping my token now. And I'll go ahead and take a look at the differences between them. And I want to explore what it means to be an admin versus a non-admin, not elevated versus elevated, because this is an important concept. It's unlike any other shipping operating system in the world. The concept of have the exact same you, one with lots and lots of power, and one that looks like a standard user without being a different identity. If I go onto Unix, I have me and I have root, two different identities. Here I have the same identity behaving differently. And how that works is, if I look at the details here, I have the exact same SID between the two. So I'll zoom in here, same SID. So it's unchanged, it's the exact same me. But as I scroll down, I see this administrators group changes from a regular old group to group used for deny only. See that? Boy, that pan action is not working well at all. So that's different. We've taken that membership in the administrators group. We didn't make it go away. We just said, oh, we're going to deny access to it. We're not going to use that to allow you to be granted access to do something. And as we scroll through to the end, we'll notice that all of my other group memberships are the same. I clearly do too much work, so I belong to too many groups. I'm going to go ahead and go with that as my theory. And go to the end where we see our list of privileges. For those of you who are unfamiliar with privileges in Windows, I'm going to take a step back and say, how do we define, really in the most simplistic way, the difference between a standard user and administrator? And the way you can conceptualize it and think about the decisions we make is that a standard user gets to bork all of their own stuff. It belongs to them. They can do whatever they want to. An administrator gets to bork everybody else's stuff. And that general principle tends to apply across the board. Why can you write to my documents? Because they belong to you. Everyone gets their own, so you can do whatever you want to with it. Why can't you write to program files? Because everyone else has to share it. So if you modify something in program files, you can bork somebody else on the device. We don't think of that very often because we're so used to having our one device that we walk around and carry with us and love and honor and obey and so forth. But that's the way you can think of it. That's what the permissions are. Now, a privilege allows us to go beyond that boundary. So if we look at the privileges that a standard user has, a standard user can do some things that will affect other users on the device. So we give them a privilege to do that. For example, shutting down the computer is going to impact other users on the device because suddenly the computer is going to be turned off. But if I make it so that you can't shut down your computer, that's kind of a pain. So obviously we want standard users to be able to turn off their computer. Maybe not on your server, if you have a terminal server going on, but on a standard computer, you'd like them to be able to do that. Undocking the device, the same thing. The computer's about to walk away. So that's clearly going to have some potential impact on other users, but we grant that as a permission. One of the things that we had to add was try running as a standard user on Windows XP. Then get on an airplane and leave your time zone. You can't change your time zone as a standard user on Windows XP. Why not? Because it was tied together with changing the system time. Well, why can't you change the system time? Non-repudiability. If I can change the system time, then doing something naughty becomes easy. I change the system time and I do my naughty thing. Then I change the time back. And then I make sure at whatever time I change the time to, I'm visibly somewhere else, nowhere near that device. So when they say, hey, did you go in and take all this data off the thing? No. I was at a party with the CEO. You can go ask him. Non-repudiability. You can't change the time, but you also couldn't change the time zone. We had to make a new privilege to allow you to change your time zone, which does affect other users, because you change the time zone, suddenly the clock's going to say something different. If you really want to mess around with someone, change it to be like, Algonquin time or India time, something that's like some whole hour increment off of there. But we give that privilege to be able to do that. Versus when you're an admin and you can do just about everything, right? If you talk about, well, I didn't do that one very well. Backup, restore. What the SE backup privilege allows you to do is it allows you to read anything you want to on the file system without an access check. SE restore allows you to write anything you want to onto the file system without an access check. SE debug allows you to get into any other process you want to on the device without having to pass an access check. Understanding what those things are helps you make smart decisions. I have had a lot of customers I've worked with who had turned on SE debug for all of their developers so they could debug. You don't need SE debug to do debugging. I'm running as a standard user right now in my debugger and debugging perfectly well because the only processes I'm debugging are the ones that are run by me, in which case I pass the access check. All right, so we take this up a level of abstraction, we start to see the reason why we do that. So we have a big difference. So when we have a login, how the logon process works is we actually, from WinLogon, we'll go through and create our regular old token, which is elevated, and we'll create a second token, which is filtered, and then we will create process explorer.exe using the filtered token. And the way processes in Windows works is that you inherit your token from your parent process. And therefore, since you launch most things from Explorer, they're going to be launching with that filtered token. And that's how we have those two different tokens that can be running and how we gate which ones are doing there. So then the next obvious question that comes up is, all right, great, so that's how we get from non-elevated to elevated. How, from everything running non-elevated, how do we elevate? So elevation happens from the shell execute API, which if you have something that says, please elevate me, we'll talk about the details of what that means, that has to call into the app info service. So if you turn off that service, you're going to turn off elevation. That's going to potentially launch consent.exe. And if you say yes, then we'll launch create process as user with our elevated token. My handwriting is really bad because of the scaling on there. I apologize for that. Hopefully you can make some sense of that. Let's walk through it. Shell execute. Let's talk about the ramifications of that. Why shell execute? And what's going to potentially break because of that? Because there's two different ways you can make a process. And in the end, it also goes through one. Create process is how new processes get made on Windows. So, okay, I'm going to create process. But create process can't do an elevated application because it can't go through the elevation procedure. And the reason why is because of the refactoring work that we've been doing in Windows to build things in layers. The refactoring work really comes from having a product that's been around in some shape or form since the 1980s and into the 1990s. Windows as a platform, a lot of the code has been around a long time. And as a result, some of the code gets convoluted. And it got to the point where just getting Windows to compile was really hard. And getting an order in place, you'd have all these circular dependencies where this DLL A would need to depend on DLL B, which depended on DLL C, which added a dependency on DLL A. And now which one do you start with? You've got a chicken or egg problem. So we said, let's try to simplify this and organize things into layers where if you're in layer 0, you cannot call anything at a higher level layer. If you're layer 1, you can call 1 or 0. If you're in layer 2, you can call 2 or 1 or 0. It was an attempt to bring order to the madness so that you reduce the number of dependencies that took place here. Now, create process is very fundamental to Windows. You can't really do anything without process. There's a container in which threads run and all code executes. So you need to be able to create a process. It's in layer 0. Now, what about the UI? If you talk about elevation, I have an elevation prompt which has a window in place. I have to read group policy, and I have to go through and interact with the user and make decisions, dialog boxes, and so forth. There's quite a lot going on. That's not in tier 0. Because what can you do in Windows without a process? Nothing. What can you do in Windows without a window manager? You can be an entire shipping SKU of Windows. So we can't take that dependency. That's why create process doesn't work, and we have to use shell execute. So from an app standpoint, if I'm using shell execute, I have to redirect that. We can do that. There's an app-compat shim that will help us do that. But it's something to be mindful of. This is why elevation works that way. So as we kind of shift gears into the IT pro side of things, the way that we do that elevation is driven by the group policy configuration. And I know that that's really, really small, because for some reason when I shifted my resolution, it decided that I might like to have, instead of 150% screen zoom 0, which I think is awesome. That's a great feature. So I'll just be using zoom in. Take a look at this, and we'll take a look at the policies that impact how we do that. So they're all grouped together here under my security settings and group policy. And when I think about what should I change, I gave a session yesterday that talked about app-compat, and what I'll say is I think the single most important thing you can do with the policies you have in terms of making yourself more agile is to leave everything alone to the maximum extent you can. It's great that it's configurable, and if you have a reason to have an exception, then take that reason. I need to implement this scenario. But the behavior that so many people went through of give me the list of all the group policies so I can go one by one through them all and pick the best choice from each of them is turning out to be bad behavior, right? And we're starting to see the number of support cases that we get in Microsoft support based upon how you choose to configure the product growing very significantly in terms of the percentage of issues we see. In the case of UAC, I just want to think through some of the really critical scenarios. There really are a couple of important things to be on the lookout for here. So the first one is this policy right here, run all administrators in admin approval mode. Now, one of the comments I've often made about group policy is that I've come to the conclusion that the way we name group policies is we get a bunch of people in a room, we put keyboards in front of them, and then they just smash their face onto the keyboard, and whatever English words come out, they use. This is UAC on or off. I don't know what all this silliness is about run all admins, it applies to standard. It applies to everybody. This is the master switch. Turn this one to off, and everything goes away. Turn it back to on, and everything comes back. So even though we don't give you a nice slider that goes all the way to off anymore, it's still in group policy, and you should be careful of it. And as I hope to try to persuade you, turning it off would be a catastrophically bad idea on Windows 10, or even Windows 8 and Windows 7, although to a lesser extent, still a very important extent. So the two that you might want to fiddle with are the ones that are, hey, what do I do for my admins, and what do I do for my standard users? So when I dig into those, I'll talk about my administrators first. We'll zoom in here. And we've got a couple choices. Do we want to, what we've defaulted to is, you know what, we've got quite a few binaries that, if you're a legitimate admin, we got, I'm going to go with euphemistically, a little bit of feedback that people might not like prompts. it's very soft and subtle, right? You didn't hear it very vocally or loudly or blaring across the press at all. That never happened. But they didn't care for it. So we said, what can we do to reduce the number of prompts? The challenge we faced is twofold. Number one, the spike that we see in the first week of use of the product when you first install is a huge number of prompts because you're installing everything. And you see a prompt for every single install. So the prompt fatigue sets in big time. The second thing is a lot of the influencers are IT pros and people who run shops that run legitimately a lot of software that will generate a prompt. So we tried to think of what can we do to eliminate prompts for those people because they really are driving the decisions of whether an organization should go. And how we do it internally is a Windows application that has a manifest that says I'm safe to launch because I don't accept command line arguments that could be potentially trivially easily driven by a bad guy is low. I'll caveat that with we don't consider the UAC boundary to be a security boundary. We try to be as smart as we can about it, but it's not guaranteed to be impermeable. You can, of course, go for consent by itself and say, ask me yes or no for everything, or go all the way to prompt for credentials, make me type my password again. Now, there's a couple of variables here which are really added just to support the slider. Do it on the secure desktop or not. And there's a separate group policy for that, just to make things doubly interesting. Switch to the secure desktop. Both policies have to line up in order to get this to happen. But the idea behind the secure desktop is the secure desktop will actually switch you to a different desktop object in Windows. Right? And to understand that, come on, scroll. There we go. You have in Windows a collection of logon sessions which contains a collection of desktops which contains a collection of windows which can contain a collection of windows. Right? So if you look at the actual objects, the GUI objects in Windows, right, a window can have a button, and the button itself is probably a window in most cases. So you can have multiple desktops. In fact, we make that even easier in Windows 10 by saying, here we have this, and I can make a new desktop, and then I'll pop a new one for you. I can click over to that, and now I'm in a brand new desktop which has nothing useful on it, and I can click back over and see my other desktop and desktop number 1. Why would we put a secure desktop on there? Because the boundary of a window message is the desktop. And you would have to have permission to send to that desktop, and that makes it harder for people to send a window message and drive that dialog box and just click the button for you. Windows does not have authentic user gestures. We cannot tell the difference between an actual physical mouse clicking a button or automation clicking a button. Great if you're writing automation, but not so great if you'd like to ensure that an actual human decided that. So we put in a policy that says, you can switch to the secure desktop and get that guarantee as well. To me, the decision comes down to, how is my help desk going to help the end user? If the help desk is going to do something that requires elevation, we can have a whole security conversation on how to best support from the help desk. But they're taking your existing process. If they want to do a same desktop elevation, they will not be able to with a secure desktop unless they happen to use MSRA.exe, Microsoft Remote Assistance. There's no other product on the market that I'm aware of, including Microsoft's, that will remote the secure desktop. So the person who has the password doesn't see it. Taking it off the secure desktop allows that person to actually see it and interact with it, or if there's any elevated windows, to interact with them. Right? That secure desktop construct really depends on how do I have my help desk do remote support and remote elevations. So I have this ability to go through and control what do I do for my admins for elevation. A fair question to ask, which we will next endeavor to answer, is, well, why does stuff elevate? And most people go in with the belief of, elevation is based on the fact that you need to do something admin-y. We do not look at the entirety of a program to determine whether or not it needs to do something admin-y. It's difficult to ferret that out, right? Particularly because admin could be writing a file to program files. Well, how do we know? We'd have to go through and chase through data or input, and there's so many different variables that you would never want to wait for the program to launch for us to go through and execute all of that logic and still potentially get it wrong. So we don't make you wait. We have to try and guess. So we try to make some smart assumptions, right? So the first thing is, let's assume that most things don't need admin rights. Great, so we'll do it there. And then we'll say, if you'd like to prompt for admin rights and get them, then you as a developer can include a little bit of XML that says, please elevate me, I need admin rights to do my job, and that'll trigger a prompt. So the developer asks for it. Reason number one why you might have admin rights. But then we had to think of other reasons. Because the problem we had to solve next was, well, really based on data. So if we think back, and this is all the way back in like 2005, we used to every single day, and we still do today, right, run a battery of tests on applications to say what used to work on the previous Windows OS still works on the current one. At the time of Vista, it was about 1,000 apps. Today, we're well over, like, I think 6,000, 7,000 at this point. Every single day, the build completes, and it kicks off a bunch of application tests. And we measure, right, what's the success rate so we can understand the impact we're having on the ecosystem. Now, the beta 2 builds, so the day after the beta 1 shipped was technically the first beta 2 build. The beta 1 builds, we had a success rate of in the high 90th percentile. It was really good. We hadn't done that much to break stuff. The beta 2 builds is where we introduced UAC as on by default. So the very next day, we went from the high 90% to 20%. And we said, oh, crap. That's not good. Why were so many things failing? Because most of them didn't install. Why did most of them not install? Because they were set up that .exes that we had no idea needed elevation. The developers hadn't asked for them because they wrote them before Vista existed. They couldn't have possibly asked for it. There wasn't an option to. So how do we retroactively fix that? We have to go through and look for setups. Now, the setup heuristics, the tool I'm using right now is the Microsoft Compatibility Administrator tool, which ships as part of the Application Compatibility Toolkit, which for reasons unknown to me, actually kind of known to me, is kind of hidden inside the Assessment and Deployment Kit, or the Windows ADK. So you go grab the Windows ADK. If you just search download.microsoft.com, if you find one, it'll probably be an old, like 5.61. Get the ADK, you'll get the current one. Compatibility Administrator has a 32-bit and a 64-bit variety. We're not going to use it for fixing apps today. We're going to use it for seeing those setup heuristics. And here's one of them. Setup. So you look for the word setup, and you'll find all the things that will trigger us thinking you're a setup. If we look in the string table, and the internal name includes setup. So star, setup, star, right? Really, very, very straightforward. Or, for those of you who are fluent in Japanese, that is full width and half width katakana for setu appu. Really simple stuff, right? This is a setup. And if we scroll down to the bottom, here's just the name, if the name includes the word setup. And you can try this yourself. Take any old app you want, rename it to include the word setup, and all of a sudden a little shield's going to appear on the icon for it. Setup is one trigger. We also have update. So the word update will trigger it. Let's go back to the beginning. Install is actually hidden under installer detection. So INSTAL and patch. And patch, and we're smart enough to try to exclude dispatch and dispatcher and WI dispatcher and AD patch.exe, but otherwise we catch everything else called patch. Go back to the beginning again, and I'll tell this one, by the way, turned out to be a real big problem for one of the customers who I was speaking to actually at a previous TechEd event, this installer detection. So a couple of stories where this triggered it. But you can see that's not exactly the world's most comprehensive, guaranteed to never have a false positive logic, is it? One of the final escalations we had, which, you know, one of those get to the airport right now type of escalations, was right before we were shipping Vista in January of 2006 for a major electronics retailer who said, our stuff cannot be loaded on this because they happen to have a binary on there called content updater, which triggered the update heuristic, which was prompting for elevation. And we had to quickly shim it up because they didn't have time to recompile with an XML manifest to get to stop prompting. This heuristic caused people to have to turn off the heuristics altogether. I had one customer that happened to, they're actually a customer who's here in the, the vendor area on the showroom floor, called Flexera. They have a whole division in their company called Install Shield. 100% of the stuff they make triggers setup detection. So everything prompted. That was not so fun for them. Like, all right, we'll turn that off. That also is configurable via group policy. So that's how we determine whether or not you need to elevate. Did the developer ask for it? Did setup detection trigger it? And beyond that, it's did the IT pro who's running compatibility administrator go ahead and ask for it, because we have flags for that as well, which are listed out here: run as admin, run as highest, run as invoker. I can trigger it that way as well. Really a very simplistic logic, but that's the reason why something might run as elevated or not, and what you can do about it if we get it wrong. We also have a specific non-installer and a specific installer. So if it's not an installer, this really flags it, I think, better than run as invoker, because you're saying the reason why I'm putting this on here is because installer detection is tricking it. It's just a breadcrumb. Why did I put that on there? Oh, yeah, because we think it's an installer, and we fix it that way. So that's elevation. We've got 2 tokens, and beyond tokens, the other thing that we're doing, and if you were eagle-eye watching what was going on the screens here, you may have noticed it. The very bottom level here. Mandatory level. That's the other thing that we put in there that helps us gate security, which is let's start to tier, not based just purely on identity, but also based on trust. Because the legacy model said, if you are Chris Jackson, you get to get at everything that Chris Jackson gets to go to. And the problem is not that I don't trust me. I'm a pretty trustworthy guy. I mean, look at me. Well, you'd trust me, wouldn't you? The problem is, do you trust every single app you might launch to the same degree? And the thing is, you may not. So if I start to look at what this is, you can actually see in its SID, this will tell you S1-16 is integrity, 8192 is the level. So the way this is represented internally in Windows is it's a 32-bit number that determines its integrity level. So technically there are 4 billion or so different possible permutations of integrity level. We thought 4 billion was probably a bit overkill. We're using about 4, leaving us 3,999,999,996 to go. Lots of room to grow and expand. But to simplify that and say, listen, there's certain levels of trust on your applications, and we'll give you the ability to do that. Let's go ahead and sort by this. So next I'm going to pull up a tool called Process Explorer by sysinternals. Anyone not familiar with Process Explorer? So at 100%, that's awesome. Clearly you've been reading Aaron Margosis's book on the subject, so that's great news. So let's go through and see that I've got, I'll start at the top here, system, so the highest level you typically see, then going into high and medium, and I don't have any low integrity processes. I'll go ahead and launch a browser, and that'll get me a low integrity process. And there's low for my web browser. And you can see I start to tier them. System is typically my system services. High, something running as admin. Medium, something running as standard user. Low, something I don't trust. Some tiering. And the way those checks work is we have 3 different rules that we can enforce. Every single token, an access token, a user's token, has an integrity level. Every object has an integrity label, or the ability to have one. If it doesn't have a label, we default to medium, no write-up. So the label will have a level, right? Low, medium, high system. And it will have a policy. No read-up, no write-up, no execute-up. I find it helps to actually see that in action. So what I'm going to do now is I'm going to use the PSExec tool, and I'm going to launch Windows. I'm going to get this. Wow. I'm going to pick the 32-bit one, just in case I want to futz around with it later. Here's Notepad. But I launched it with the /L switch in PSExec, which lets me, I'll use the window finder to go find it. The window finder will hide this window. There we go. Here's Notepad, and it is running at low integrity. Because I futzed around with it. Because I said, PSExec, you take care of making it low integrity. It swapped out the medium integrity label for the low integrity label, and off we go. So now it's running at low. I'm going to go ahead and type some text, and I'm going to try and save it. Right? Because remember, identity-based would say, hey, listen, my documents, they belong to me. I get to write there. And you typically don't have a problem writing there. But because I'm running it low, I'm going to go ahead and try to write to test.txt. In fact, I'll just do file.txt, just in case I've already mucked with that text one. And it's going to give me this lovely error message. And from having worked in AppCompat for a number of years, I have learned that error messages love to lie to you. This is going to give me the very helpful suggestion, hey, why don't you put it in your documents folder? The exact place I'm trying to write. They didn't bother to check that that's where I already was. Why? Because you'd have to be kind of an idiot to be trying to write there in the first place. Turns out, they always can make a better idiot like me. So I can continue saying yes and put myself into a perpetual loop and get this problem here, because I'm not allowed to write there. It's medium, no write-up. I'm trying to write, so it's not allowed. So what can I do? So first of all, let's go ahead and make file.txt. So we'll go into Documents, and we'll make a new text file, and we'll just call it file.txt. There we go. And then we're going to change the integrity label on this file. I'm going to use a tool written by Mark Manassi, who's also here this week, if you want to go see one of his sessions. File.txt. Let me actually get to Documents, CD, Documents, CHUML. File.txt, and I'm going to make it a low integrity file. And great, it has no integrity label. It's treating them like this. Oh, it didn't. Oh, I typoed. I've got a typo problem today. Let's try that. Successfully changed, and now that it is marked as low, I'm able to write there. It blocked me from writing down. I changed the label, and it allowed it. That incidentally is exactly what we had to do for Internet Explorer, which runs at low integrity. It saves its history. Well, you were not allowed to write to its history, so we had to make new directories that are marked for allow low integrity processes to write there. Right? But you can see we're starting to build this striation. Here I can have untrusted apps, slightly more trusted apps, admin trusted apps, service trusted apps. This layering. Now that layering is great when you have a select number of specifically untrusted applications. But there's some problems that we need to go and resolve later, which is what if we want to take this whole concept of building things based on trust, distrusting things by default, which is a good idea for strange apps, right? When you start to look at the numbers and you see the sheer number of applications you can download off the internet, the numbers will tell you that up to a third and maybe even more of all binary executable files you can download for Windows off of the internet at large either are or contain malware. It starts to scare the heck out of you. It's like, wow, this is no longer a trusted platform. I want to mistrust everything by default. And the problem is if I mistrust everything by default and I shove it all into low, once everything's in low, it's no longer protecting me. Because now they're all in the cesspool together, but now I've got stuff that I kind of trust, right? I'll run a mail app, which has stuff that I kind of like the bad guys not to be poking around in, so it's an incomplete solution. The other half that's incomplete is we've got to make sure that I can't use other mechanisms in Windows to drive it. So let's flush out those, and then let's start to get into some of the Windows 10 modern app things that we have. There's our lovely PowerPoint window. I just love that. And talk about how Windows itself works. So I'm going to launch an application now called Spy++, which is something that we distribute as part of Visual Studio. And what Spy++ will let you do is it will let you see just how many windows are running on your system. And most people who haven't gone diving into this are usually a little bit surprised by just how many windows there are. Windows is a message-driven architecture. There aren't objects with properties. Windows send messages to one another. That's how the communication works. and window messages do not have security descriptors. Windows don't have security descriptors that impact the ability to send messages to them. The desktops do, but there's a single message engine, message queue, if you will, for the entirety of a given desktop. So these are all the windows that are on there. And go ahead and launch an application. Here's an app that's doing that, and I can go in and I can see all the messages that are being sent to a given window. Now here's what I'm trying to show here. I've got a window that's creating an out-of-process COM component that is allowed to add new users to the device. But the window that it created is running at medium integrity, and I can see it here. It's medium. As such, anything else running with the same level of trust is going to be able to send a message to it. So if I'm a bad guy, let me actually get the find window. I want to get that guy there, and I want to see all the messages that are being sent to it. I can send window message to it and automate it. And boom, I just created my user without any hands on the keyboard. And you can see the messages that are being sent. They were all captured here. This is exactly how it was done. It was sitting there sending all these messages, get the text link, send the command, key down, key down, key down, key down, typing all these different things along the way. Purely automated. So that's the problem to solve, which is, all right, so great. If I can make sure that the application itself is untrusted, but if I get another app on the desktop, then it'll just send messages to it and drive it. So let's say I'm in the web browser. I'll just send a message to a window I'm pretty sure is going to be there, because the start button's a window. And then it's going to pop up, and I can start typing on there, send keyboard strokes to that. That'll automatically default to my search on there. And I can start doing some driving things so I don't myself have to be elevated if I have a buddy who I can say do something on my behalf. So how do I solve that problem? We solve that through something that we call user interface privilege isolation. And that is, if I take the window and I put the window at a higher level of trust, so if I look at what this guy is, grab this window, that window is running in high integrity. And we have a very straightforward set of rules. You can't send to a higher privilege window, period. That's easy. There are a few pinprick holes for things that are being done. You can open up more if you're a developer. But by default, they'll be closed off. So now when I try to send messages to it, nothing gets sent. In fact, if I go and grab this window itself, say, show me everything being sent to that window, the window manager just says, yep, nope, not giving it to it. Doesn't even try. It just disappears into the ether and it goes away. So we can protect from UI automation-based attacks, but now we've got to solve the problem of, well, how do I protect you from someone going through and getting into the cesspool of Windows apps and going across, the lateral traversal of apps, if you will. So that's the next layer to go and address. So for that, I'm going to do a little bit of code. How many people here are developers? Is anyone here a developer? So a couple of folks. All right, so the rest of you IT pros? Beer aficionados? I mean, what does everyone else do? You're not a developer or an IT pro. Why are you here? So I'm not going to go heavy on the code. I'm just going to explain exactly what I'm doing so we can talk about it. So in this case, right, I've just got an application. I'll go ahead and launch it. But it's going through and it's having a bunch of different buttons to create files. So we'll launch the application. And we'll wait for it to launch. Oh, I should launch without debugging. In fact, I'm going to. I don't like waiting for symbol loads because it's going to be reaching out over the internet, competing for bandwidth with all of you fine folks who are rapidly tweeting about how I'm doing crazy code stuff at a 200-level session up here. I didn't give it a 200 label, so that's a whole different story entirely. Let's kill this guy. All right. Given that I'm impatient, let's see if I can launch Visual Studio faster than it can stop debugging. Yes, yes I can. That is fantastic. Oh, it's got to prepare the solution. All right, see who's going to win the race? Oh, it's still stopping. Cancel. Okay. Did we stop here? All right, so let's debug. Start without debugging. There we go. Deploy. No, I don't want to debug it. Boy, this is going swimmingly. No, God, really? All right, let's kill that one. Stop. Oh yeah, it's probably caught in a debugger and it's really confusing it now. So, let's dig into what the code's doing while I wait for Visual Studio to catch up with us. It's really very simple. What I want to do is I want to showcase how we're able to interact with the system itself from this layer of protection. So the first layer of protection that we're doing in a Windows application is we're running it at low integrity. So if I launch the application, I think we're ready to go now. We can go in and we can see that we're going to have an integrity level built into it. Really? Really? All right, so we'll get one launched. You know what? Let's launch the calculator. So, of course, Cortana is not going to cooperate with me today. So we'll go into All Apps. I love beta software. It makes my job so easy. So let's take a look at it. What I always say about my job, by the way, is that I can never have a failed demo. I can just have unplanned debugging demos. We're having one of those right now. But let's look into what we're doing here. So we actually have an application that is being hosted by the application frame host. So that's fascinating to me that we're doing it that way. So that's not going to be, what is this? Invalid argument exception. The parameter is incorrect. Where are you breaking? Really? Let's clean. Rebuild. Start again. All right. So let's get a Windows 8 app. Boy, this is awesome. I love when demos go like this. Let's go into what's a good here? This is a Windows app. My mouse control panel, a nice modern application. Let's go in and take a look here. And we can see that here is the process. We're going to dig into the contents of the security. Now, one of the things that we're going to see is that we have an integrity label, and it's the exact same thing we saw in our low integrity process before in IE. S116, that's the integrity SID namespace, if you will, the value of 4096. It is running in low integrity. But low integrity itself would put all modern applications, or you know, what we used to call Windows Store applications, we now call universal applications, or Windows apps as opposed to Windows desktop apps, all in the same plane and all similarly untrusted, but they can all get into each other. That's not desirable. So how do we start to build partitions between them? And that's where comes the idea of the app container. Now, this is something that's been gradually evolving over time. Applications used to not have an identity on Windows. Windows Vista introduced the concept of a service having an identity because every service gets a service SID. And that service SID can be used to allow or deny access for that specific service only. It was generated based upon the name. Now, the app container SID is something that is unique to each universal application on Windows 10 or to each store application on Windows 8.1. It is part of its identity. It is generated based upon a hash value of the application the application's name and vendor, I believe, which is why we have the uniqueness constraints when you submit to the store, so that it will be the only one that generates that particular identity. And this, the presence of an app container SID, determines what you are or are not allowed to do. Did we start? Did we start? Come on. Oh, unbelievable. This is so unawesome. It's almost unfathomable. All right, so we're going to have to figure out how to. We'll do more of a code-based demo as opposed to the fact, and I think there's something about the sizing because of the scaling, because this all worked swimmingly literally half an hour ago. So we're going to go through the code and talk about what can and can't be done. So as we go through, and I want this code, I want the application code. And apologize for the code-based demo. This looks a lot better on the screen, but thank you for updating my software with the Windows Insiders program. So here's what we're trying to do in the first place, which is we're trying to write to somewhere. Let me get to the code itself. WinRT, dialog, Win32. All right, so here we were creating in the documents library. And the documents library was going to, let me see if I can actually launch it directly from here. I really want to just run it. Crap. All right. Apologies for the demo glitch. So we'll explain what's wrong with the code to a bunch of people who mostly don't code. That makes for fantastic showmanship here. Trying to write to the documents library. Because you're in low integrity, that's going to prevent you from writing to the documents library, but there is an additional layer of protection. That additional layer of protection is that I not only have to have the documents library allow me to write there, like to get past the low integrity, I would also have to have permission for my app container. The existence of an app container SID inside of a token, so if I go back to Process Explorer and I see this token, right, having an app container SID is going to enforce an additional rule to check to see, does this app container have permission to go in there, or do all app containers have permission to go in there? Now, in the case of going through the new Windows APIs for a modern application, it has pre-programmed logic that will say, oh, well, go ahead and ask a parent object, something running at Medium, to do it on my behalf. A broker object. And the actual name of the binary is runtimebroker.exe, and it will do the file writes typically. But what the file write will do is it will check to see whether or not you have a capability that would allow you to write to the documents library. Now, that capability was so overused that in current versions of Visual Studio, we don't even show it to you. Because it was designed for a specific purpose. But I could add that capability. These capabilities are flags that are sent to the broker object to say what should it be allowed to do based upon the actual efforts I'm trying to go through and achieve. So that's a capability which would inject yet another SID into the token of that process. So that's how I would go through using the create file async, which is a new modern API. Now, if I were to write code like I did in the past that said, you know what, just go through the create file API and write it directly here using a hard-coded path, because that's what all the best app compat people know how to do, what's going to happen is it's going to simply get access denied. Flat out, bonk, you're done. So great, so access denied, how do I get access granted? Then I would have to overcome the fact that I have access granted from an integrity process by flagging it as low integrity. And what I will then find is that that is not enough. In addition to low integrity, I would have to grant access to that specific object or to all objects. So if I go into this file and go into the security tab, go ahead and zoom in on this, make it easier to see, I can edit the security tab for it, and I can add there we go.
And I'm going to pull it from the local machine, which means we get to wait for it to ask the network, hey, what other objects might you want? Let's go ahead and make you wait because I'd hate to have some really fast and easy way to get to local. Off of this device, show me everything. So in addition to being able to enter that specific SID, there's also an entry for all application packages. So when I'm setting the security descriptor for the object, I could say all application packages are allowed to write here, or I could say that specific one is allowed to write here and inject that. Because that SID becomes well known as soon as you have the same vendor and application name so that that can be used ongoing to gate that access. So I would have a two-step process to allow a standard Windows API to work. I would have a process number one that would allow me to have a low integrity object writing there because low integrity is the first check that happens. And secondarily, I would have to allow that specific app container or all app containers to get there. Now, given that I'm now doing this all 100% without any actual applications to show you, I want to pause for a minute and say, have I managed to construct any valid amount of sense from this? Or do I need to continue to try and do contortions to get the apps to running? Is this making any sense at all without the actual app running? OK, so we're doing it. It's way better with the demo. But apparently the demo does not like running with change resolutions. The third example shows how we expect it to be done. When we think about application design, what is it that we hope that application developers will do? So number one, you're going to get some storage space to store application data. You'll get to write there. So we say, if it's something that should be hidden from the user, just put it here. You get your own private bucket for it, stick all your things in this bucket, and everything is OK. But if you're going to save a document, the user wants to create something, the answer and the solution for that is just ask the user where they want to put it. The runtime broker will accept the vote of the user as being, oh, you have permission to write there. It's very, very similar to what we do in Internet Explorer. So if I look at how Internet Explorer runs, it doesn't have an app container per se, but it has a low integrity. I can go in and I can launch Project Spartan, and it will actually run inside of an app container. If I go and take a look here, and here's, let me just go to, other than random pictures of my friends and their kids, I'll go to Bing. But I can go into Spartan.exe and see that it too is running in an app container. So there's the app container. There's a list of capabilities, and there's the integrity, which is low integrity. I can see that it is yet another modern app. So it'll have to go through the same process. So here's where we think through the design process. I want to save a picture. I'm in low integrity, and I'm inside of an app container. So I'm not going to have any luck saving a picture. Let's say I go and find a picture of, I don't know, goat taco. There's a random word. Let's hope it doesn't. If that brings up anything naughty, that's going to be the weirdest sight in the world. I've had worse happen. On a related note to that, for our internal conference at Microsoft, I run a whole track called the hardcore track, which is this would be like the entry-level stuff for this, and we haven't had anything that's not sort of under the covers here. It turns out that's a terrible name for a track if you do web searches for advertisements for it. Now I know. If I were to try and save this picture, I don't have permission to write there. I'm in low integrity, and I'm in an app container, so I can't save it to my pictures directory. But who can? The picker host. This is the broker pattern yet again. So you have a broker, in this case pickerhost.exe. The broker says, I'm going to enforce some rules. If the user's picking it, I'll let you write there. If the user's not, you won't be allowed to. In Internet Explorer, you don't have the framework to build upon. This comes from the new modern app framework, the Universal Apps or Windows Apps framework that gives that to you. Internet Explorer, that didn't exist. They had to do it themselves. They had to have the medium integrity process, which is, incidentally, when you look at the process layout for Internet Explorer, which I should have running right now. Do I have it? Oh, I closed it. That's awesome. You will see a parent and a child. How IE does it is the parent is the broker. It runs at medium, and the child is at low. And it implements its own. Here, we just go in and we have this broker process, pickerhost.exe, and it has permission to do it. It's running at medium integrity. It behaves like me, so it has the ability to write there. The user intervenes, it enforces the rules, presents a UI, and gets you past that security boundary, and then just pulls the information from there. That whole broker process architecture that allows me to do that. Everything else will not happen by default. And the overall design goal of that is this allows me to still get onto the system, but not have it do it without my knowledge. Browse to a website. The website can't just throw things on your file system and you don't know about it. You are involved in that decision if something is going to show up. Otherwise, access denied all across the board. You're walled in within your app container, and you're walled above at low integrity, keeping you in your box. And that's really the design. How do we build a trustworthy architecture wherein I can design an application and it can live by itself and not be able to muck with the other things that are on my system? Because this is more and more becoming a difficult decision that people have to make. And I have this conversation a lot, right? When you start to understand what's going on under the covers and what we're doing to invest in having a trusted architecture, what's probably, what would you guess is the most common question I get when people first start exploring Windows 8.1 or Windows 10? How do I turn off people's ability to access the store? How do I make sure Angry Birds never runs on my devices? Number one question. It's never not happened in a conversation that I have. And as you start to think through, well, what actually is the impact? What could Angry Birds do? It's very, very different from, hey, what if I allowed you to go to Best Buy and buy whatever game you wanted and installed it? Or download whatever you wanted to from the web and install it. Then you don't know what it's putting on there. You don't know if it's throwing a keylogger onto the system, if it's throwing other kind of spyware, if it's going to be suctioning things off or putting in a back door. There are all kinds of negative things that could happen. But if I build a platform that starts to build this defense in depth that says you are stuck in your container, number one. Number two, we have process on top of that that helps to ensure that whatever is in there is something that's trustworthy. It's not just, hey, whoever submits it, that there's a validation process of the application, that it does something useful, that it doesn't try to break the rules, that it all looks sound, right? In the Windows Store, public store, that's something that we bring and provide as part of the equation. If you are sideloading your own applications, it's something that you have to bring. The human review side of the equation. Is this coming from a trustworthy source? Is it signed? Is it not tampered with? Is it doing anything that's useful or productive to allow me to do that? But with that context, then suddenly I have a very different conversation. If putting an application, the only real impact is, statistically today, that it's going to take up a little bit more of my hard drive space, which is a corporate asset, but I have someone who's traveling 200 days a year and they might want to play some Angry Birds on the airplane, that's suddenly a little bit safer. And that begins to change the conversation as I start to think about bring your own device and how do we start to containerize and isolate things, right? And that's a lot of what's been going on in Windows is how do we do isolation? How do we do containerization? How do we make it such that you can have your multiple personalities on the same device? Because no one is going to carry around, there are still a few people I know who do it for phones because phones are pretty small, but not many people are going to bring, I'm going to have my tablet from home, my laptop from home, my tablet from work, my laptop from work, and it's this big bundle of devices. There are a few guys who work on the Windows team who do that because they show the devices, but other than that, you don't. That's the overall end goal. How do we build a trusted platform upon which you can build and install and distribute applications? we go through, I won't do one last bit of code. I know we don't have a lot of coders in here. But one last bit in here. But one other thing we do is we even isolate our objects. So it used to be that if you created an object, and here I'm just going through and creating an object using create event, which for any developers is just creating a kernel mode event, which is going to wait for a flag. It's manually triggered. But events are scoped in one of two ways, machine-wide or logon session-wide. And so one of the challenges that we would often have is we'd have session squatting. If you knew someone was going to name an event one thing, there could only be one event named that within that scope, whether it be session or device. So create an event that you want to hold before someone else gets there, and they call create event, and they don't check to see whether it exists already. They might get your event, and suddenly you're listening in on them. If you open up, for example, a file handle, right, your kernel mode representation of a file mapping object, and you get there first, someone else opens up, and you're going to see their data. Well, that's not good. Now you got someone snooping on you. So how do we prevent that? Well, events will be created inside of an application-specific namespace. They'll be prefixed with that app container ID to isolate it that way. So around the board, right, so when we look foundationally from the beginning all the way through to the end, it all starts off with UAC because, oh, by the way, UAC is the master on or off switch for all of this stuff. Mandatory integrity control, turn off UAC, it goes away. App containers, turn off UAC, it goes away. All gated on the foundation. User account control and this notion, even if you don't have multiple identities, even if you don't elevate or not elevate, if you're a pure standard user, everything else is built on top of this. So when we look at what the cost of that was, the cost on Windows 7 of turning off UAC, prompts go away, that's my benefit. What's my cost? Well, I lose protected mode. I lose mandatory integrity control and UIPI, which means I don't run my web browser at low integrity, which means my web browser runs as me. Oh, and by the way, if I happen to be a local administrator, then I've just made the internet the local administrator of my device. That's a consequence. And that may or may not be something that's important to you. But then when I move on to the next level of, well, what about in Windows 8.1? What does that mean? On Windows 10, what does that mean? That means I'm not even going to run any modern apps. They're flat out not going to run. So I lose access to all those applications. I lose the ability to run Spartan, a modern app, or Edge, sorry, now it's Edge. And that whole isolation platform and a lot of the benefits all go away. The other thing that happens is because it's so core and central to everything that we do zero testing with UAC turned off. We have no idea what happens. And there's a lot of weird stuff that happens, right? Because I run into the bugs that do that. I worked with one customer, and they had turned UAC off, and when you go to, I got to remember the exact scenario, to create a new tab in Internet Explorer 11 under some circumstances, it would pop a new window instead of a new tab because the check was checking to see, hey, was it protected or not protected, and it was getting tricked by the fact that UAC was turned off so everything was running at full rights. So it was poorly written logic, so technically a bug, but a bug that we're like, well, why would you run with UAC turned off? Then because is that going to get fixed? And we would have never seen it coming. We don't test it that way, so that adds more risk as well. So from start to finish, right, foundational, UAC is the basis of all of this. Now you have a trusted application platform. So as I'm thinking about where to invest, if I want to put in partitions, this is a conversation I have a lot around modernization. Partitions come from the app platform. If I put everything on the website, I get the partitions that the web browser enforces, but there still might be some way for communication to go back and forth depending upon how I happen to construct them. If I want to deeply isolate them, make them more trusted, but give them some access to my system, that allows me to do that. And helps me make the right decision there. And it all becomes very foundational. So as we add complexity, we add capability, and we add trust. And in the end, that's what we're goaled with. So with that, I'd like to thank you all for coming out this morning. Hope it was useful, productive, and nicely 200 level. Got a couple minutes for questions if you want to hang out.
Such as, why don't you demo it at 1920 before you show up? That might be a good question. I'll tell you, it's fair feedback, right? It's like, the mic's not on. You can just talk.
Do you plan on enforcing UAC in the future where you can't turn it off?
Do we plan on enforcing UAC to where you can't turn it off? I am unaware of any plans to do that. You can still do it in Windows 10. What we try to say is that this is a bad idea. We try to make it harder. But there are some scenarios where you might want to. And one example is on server, on a well-managed server, and my friend Aaron Margosis, who's actually presenting here this week as well, wrote a KB article on the topic that said if you have a well-managed server, it may make sense for you to turn it off in some scenarios. So we wouldn't want to make that code path go away entirely. On client, I would say it's not a good idea, but would we ever just say, no, you can't anymore? If we were to do that, what would be likely to happen is that someone would create some workaround or a third-party product that did it anyway. Much like when we said you can't have a start button anymore, what's the first thing that other people did? They made a new start button for you. How about what?
Enterprise lockdown devices where the root are trusted in the TPM and you can only run the apps that are signed with the...
Yeah, if you're controlling the device, I mean, you don't even need device guard. You could just have a standard user login, and with a standard user login, you can't turn off UAC. If you're admin, you can still go in and turn it off today, right? But can you lock it down so that an end user can't do it? Absolutely. You don't even have to go to that level of rigor. You just be a standard user, and you can't do it. There's probably nothing better you can do to protect your workstation tier than to make people standard users.
One more question.
Yeah.
I see this future coming of this app isolation evolving to the point where we can start managing applications on quote-unquote non-trusted machines or non-managed machines or devices. Can you give us some insight as to those next steps and where we're headed so that it's more of a mobile application management
Yes.
versus the device?
Yeah, I understand that. So basically, the scenario is what when we kind of brought up a little bit, which is on the whole BYOD scenario, which is kind of what a lot of people would solve with today is with something like Good, where it's like, hey, here's a little containerized world in which I'll run my stuff because I've built these walls around them. The first step that we really did was how do we make that container so that the walls are just kind of always there in general. I mean, obviously, it's going to be a long, long time before Windows desktop apps go away. If ever, right? Because there's still plenty of scenarios where I would choose to invest in desktop versus a straight-up Windows app today, just based upon what I'm able to provide and the value of that legacy code. I don't know of the specific goals around how do we start to do that both on Windows as well as on other platforms, so that I have nothing to share there, but definitely the whole concept is both ways. How do I make this device trusted? And then the flip side of that is, how do I run trusted code on an untrusted device or a less trusted device? Or how do I make a device that can have split personality? I mean, these are the kinds of things that we think of. I don't know the plans specifically, but I know there's a lot of really smart people looking at, down that path.
How about when you put .NET apps in the app V container so they go through the Windows Store in the next generation?
So .NET apps in the app V container, you'll have the isolation that app V itself provides, but it's not going to put it into an app container, right? So the app container concept is unique to modern applications, and the reason why is just the compatibility impact. If you want to experience the compatibility impact, take Internet Explorer and put it into enhanced protected mode, and then try to run some of your ActiveX controls, or Silverlight for that matter, and you watch it just blow up in your face because it doesn't work inside of an app container. So we wouldn't want to start generically applying that, but you would get the isolation of the private registry, the private file system that app V itself provides. Yeah?
Microsoft Edge is now a universal application that brings that advanced level of security, but on the other side, it allows browser extensions. So will that open the door to allow people to write malicious code just as a browser extension, so as it works on Chrome, or will the overall app container prevent that?
So by being in an app container, you'd have rights to do everything that's inside of there. I mean, that's always the challenge, is we still have given you full control of the web browser if we're running code. So the extension plan, I would say, just across the entire browser industry is run less
add in code. Binary extensibility is the way of the past. We are running a Flash as part of the browser. I'm not aware of any plans, but I will caveat this with the plans have been so fluid around Edge that what I hear one week can literally be completely the opposite of what we build the next week, just because we are really listening hard and trying to figure out really tough questions in real time. But yeah, so I would say in general, across the board, we're trying to constrain binary extensibility. Obviously for IE we have it, and we know in the enterprise it's huge, which is why we still have an IE 11, or IE whatever we call it, in Windows 10. But the idea with Edge is to be a clean slate and to not bring in anything. And we've got to kind of figure out what to do for extensions, because extensions are a problem industry-wide as well. Chrome has extensions, Firefox has extensions, IE has extensions, it does ActiveX, and none of them are the same. And the whole goal of the web is write once and run on everywhere. It should be the same code, same markup everywhere, and extensions break that model. And no one likes that, except for there are still legit reasons why you want extension. It's a hard problem. Cool.
We still have business-critical applications from Oracle that require UAC to be turned off on our Windows 7 workstation. We'll probably see the same thing on Windows 11.
So
We have EAs who have SVPs hammering on them, go to the security team, get the bloody UAC turned off so we can continue to use this app because we're not going to pay $15 million.
yeah, and that would be that to me is going to be the question: is to what extent do vendors get to compel you to do something that is in a documented way a bad idea? And it's tough because you end up with these massive dependencies, and the cost of moving off is very large. So I'm just shutting down real quick so I can get off the stage. I don't know if anyone's coming next, but.
It's not just pushing us around, but it's all the investments that Microsoft's made in this platform.
Yeah, I think it's going to be a rock and hard. I mean, it's different, and I'll say there's a couple of different things, and not to put Oracle on the spot. I try to be real candid about Microsoft doing stupid things also. And believe me, right, so I'm on all the aliases around UAC and the security infrastructure, and we still get questions every day from developers trying to figure it out, which is why I still have this session that has so much content that's you'd like, yeah, this has been around for kind of a while, right? You're talking Vista here, and the thing is, this is legitimately hard stuff. And we try to work as closely as we can with them, and we try to figure out what's the best way to do it. I would typically look for what are the reasons why it needs UAC turned off, and do we have an alternative? And where am I willing to risk it? Am I willing to risk losing my entire platform to get support on this one? Or can I facilitate the conversation and say, listen, the reason why you need UAC turned off is because of this. Because there's also a flip side of doing that. One of my favorite flip examples is on Windows 7, you could not install several versions of Adobe Reader with UAC turned off.